Hello, this is video number 10. And this is chapter 7, section 4. And this is all about sum to product and product to sum formulas. And this seems pretty basic, but remember that sum is the answer to an addition problem, and a product is the answer to a multiplication problem. So we're going from addition to multiplication or vice versa. And this is very similar to the last chapter. I'm going to give you some formulas, and then we'll do some examples, and then you're going to go do some varsity. So it's you being able to go back and forth between these two things. So first, we're going to do some product to sum formulas. Okay, and there are 4 of these that we are going to put on your page. All right, so the first one is sine alpha, sine beta. And remember, that's just 2 different angle measurements, right? So we can't use theta for both of these, but it could be sine alpha, sine theta, could be sine A, sine B, whatever these are. They're just 2 different angle measurements there. And that's going to expand into 1/2 bracket cosine alpha minus beta minus cosine alpha plus beta. Close the bracket. All right, the next one is cosine alpha, cosine beta. And that expands into 1/2. These all look very similar. Cosine alpha, these are exactly the same, except the middle sign is different. Cosine, that's what I was looking at on my paper. And I was like, what? Did I make a typo? No, that middle sign is different. So it's still cosine alpha minus beta, but then there's a plus cosine alpha plus beta. So those two look almost identical, except for that middle sign. And then we're going to have now a combo, sine alpha cosine beta. So these two both have sine, these two both have cosine. Now we have sine and cosine. And this guy is 1/2 sine alpha plus beta. Oh, I hate when those things show up. Let's just go away. Okay, sine, I need a pen. Sine alpha plus beta. And this is a plus sine alpha minus beta. And then we have cosine alpha sine beta. And that equals 1/2 sine alpha plus beta minus sine alpha minus beta. Okay, so your job, again, is just going to be to kind of mix and match the formula to the actual example. Okay, so keep those. Well, I'll bring us back to those, but here's the first example we're going to do. I'm going to go to another page. And example 1 is going to look like this. Rewrite 8 sine 7x cosine 3x as a sum or difference then simplify if possible. Okay, so 8 sine 7x cosine 3x. So what's important here for us is that we want to find somewhere where we have sine cosine, right? So I'm just going to highlight this. We're looking at sine cosine. Okay, so I'm going to go back to these formulas. And if you take a look at the left-hand side, we have sine cosine right here. And so we're going to utilize this formula to do what we need. Okay, so I'm going to rewrite that formula on the other page, and we'll show you how to expand this guy all out and utilize it. Okay, so that formula, I need a pen back, and we'll change the color. We're going to use sine alpha cosine beta, and that's because of the sine cosine. So this would be alpha, this would be beta, and that's equal to 1/2 sine alpha plus beta, and that's in a set of parentheses, and then plus sine alpha minus beta. And here's all we're going to do with that. Now, they're giving us this whole piece. All right, so we're going to kind of plug some of that information in. We need to take this 8, and it needs to go in the front with this 1/2. Now, the 1/2 is part of the formula, so it has to stay in there. But we're going to throw the 8 in there along with the 1/2. So the 8 is coming from what they gave us. The 1/2 is coming from the formula. Then we're going to take the sine, and alpha is 7x, beta is 3x. So 7x plus 3x plus sine 7x minus 3x. Okay, so now we're going to do the math here in the next step. 8 times 1/2 is 4. And then we have 7x plus 3x is 10x. And 7x minus 3x is 4x. And that's the answer to this thing. So you're just putting information into the formula and expanding out the information based on the formatting of that formula, right? If this had had 2 sines in it, then you would have used a totally different formula. If it had had 2 cosines, it would have been the second formula. If it had been cosine sine, you would have used the fourth formula. All right, so it's the formatting of this formula here that will tell you if it's going to be, let's actually number these here. You get 1, 2, 3, or 4, right? If it was sine sine, you'd use number 1. Cosine cosine, you'd use number 2. Sine cosine, number 3, that's the one we used. Or cosine sine, you would use number 4. Okay, I don't know if I have another example. Oh, I do. So that one was in just 7x's and 3x's. This one actually uses radians, and then it goes on to actually evaluate. So let's take a look at this guy. All right. So this example says use the product to sum formula to evaluate. Oh, that should be an A. To evaluate cosine 11 pi over 12 and cosine pi over 12. All right, so notice this time we have cosine, cosine. So I'm going to flip back to that first page, cosine, cosine. And we're going to notice that we're going to want to use number 2 here, cosine, cosine. And so I'm going to start by writing down this formula. 1/2 cosine alpha minus beta, cosine alpha plus beta. Okay, so we're going to start with, we're going to have cosine alpha, what is this formula? What was the left-hand side? Cosine alpha, cosine beta equals 1/2 cosine alpha minus beta, and then plus, I'm looking at my cheat sheet over here. Oops, I don't need that there. This is why you guys are allowed to use notes on all your tests. I do not think it is reasonable to make you memorize all this stuff. Out in the real world, almost everywhere, you're going to have an ability to go and reference materials in all your jobs. So cosine alpha plus beta. Okay, so what do we have here? Well, this guy, 11 pi over 12 is our alpha, pi over 12 is our beta. And so let's just expand out and see what happens. Okay, so we have 1/2 cosine 11 pi, oh, yeah, that's right, 11 pi over 12 minus pi over 12. It's nice that they actually gave you the same formula there, or denominator. And then cos plus cosine 11 pi over 12 plus pi over 12. So now watch what happens when we add these together. Let's switch colors. 1/2 cosine 11 minus 1. So this is 10 pi over 12. I'm going to take this and go over here. So 10 pi over 12 will reduce to 5 pi over 6. And so I'm going to plop that down in here. Okay? And then this guy, 11 pi plus 1 is 12 pi over 12. Right? This guy. Twelve pi over 12, which is just plain pi, right? The 12s are going to cancel each other out. And so this is plus cosine of pi. All right, well, I do not have, excuse me, I do not have my unit circle set up, but you can go and take a look at your unit circle because both of these values are in your unit circle and I have them in my notes. So I'm going to just pull those values of cosine from my unit circle. And so I know the cosine of 5 pi over 6 is negative rad 3 over 2. And the cosine of pi, which is 180 degrees, is negative 1. Okay, so now I'm just going to do some good math here. And the 1 is going to turn into a 2 over 2. And so this is going to give me a negative rad 3 minus 2 all over 2. And then if I multiply in the 1/2, I will get a negative rad 3 minus 2 all over 4. And that is the value, because it says use the, back in the directions, use the product of some formula to evaluate. That means find me a value for this statement right here. And so this down here is the value for that statement. Okay, and that's how you would use that formula to first expand, plug stuff in, unit circle, find the x coordinates, evaluate. Okay, let's talk about the sum to product formulas. All right, these guys, there's 4 of these also, and they're similar. This one is sine alpha plus sine beta. And it looks like 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. Okay, the next one is sine alpha minus sine beta equals 2 cosine alpha plus beta over 2 sine alpha minus beta over 2. The next one is cosine plus cosine. Cosine alpha plus cosine beta equals 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. Make sure you're not putting any signs in here on the right-hand side between the two trig functions, right? They're addition and subtraction on the left, going to multiplication on the right-hand side. And then over here, the fourth one is cosine minus cosine. Cosine alpha minus cosine beta equals -2 sine. Don't forget that negative. It's the only one where you've got a sign, S-I-G-N, in any of these. Alpha plus beta over 2 times sine of alpha minus beta over 2. Okay, so there's the 4 formulas. And then let's go. We're going to do the same thing. One is just going to expand, and then one we're going to evaluate. Okay, so the first one says rewrite the expression as a product or a quotient then simplify if possible. Okay, and the problem is sine 9x plus sine of x. And that's it. That's all you're given. All right, so if we take a look back at the problems that we have, we're going to be using the sine of alpha, sine of beta, right? I'm going to go back here, and we have sine plus sine. So this is what we're being given. Sine plus sine. Again, you can number these if you want. 1, 2, 3, 4. And we have sine plus sine. So we're going to expand out using this piece of information. So 2 sine alpha plus beta over 2. 2 sine alpha plus beta over 2. And then, where'd it go in my book? And then cosine alpha minus beta. Just double check. Yep. Okay, so what we've got here, this is our alpha, this is our beta, and we're just going to plug things in here. So I've got 2 sine 9x plus x over 2, and then cosine 9x minus x over 2. And then we'll simplify again. So 2 sine, this gives you 10x over 2 is 5x. 9x minus x is 8x over 2 is cosine 4x. And that's it. That's all you have to do with these. You're all done. So you have to recognize it. That's the thing, is recognizing based on this information which of those 4 formulas that you're going to use on the other page. Okay? All done. Next one. Evaluate. Cosine of 15 minus cosine 75. All right, so we have cosine minus cosine. So let's go back. 1, 2, 3, 4. Cosine minus cosine is going to be this guy. Number 4. So we're going to expand out using this piece of information. So I am going to write that down on that page. Cosine minus cosine. So we're going to use cosine alpha minus cosine beta. And that equals -2. Don't forget that negative sign. -2 sine alpha plus beta over 2 sine alpha minus beta over 2. And our alpha is 15 and our beta is 75 from the information given, right? So we're going to plug some stuff in here. -2 sine 15 plus 75 over 2 sine 15 minus 75 over 2 is negative 2 sine 90 over 2 sine, what is that, negative 60 or something? Negative 60 over 2. And be careful, right? 15 minus 75. Make sure you catch that negative on there because that affects our angle measure, which then affects what you're going to do with it. So we have negative 2 sine 90 over 2 is 45. And then sine negative 60 over 2 is negative 30. All right, so now we're talking about 45 degrees. And you should know from your unit circle that that's rad 2 over 2. Oh, erase. Okay, so I'm just putting in here the sine of 45 is rad 2 over 2. And then sine of negative 30, well, that would be right here. And the sine of positive 30 is a half, again, from your unit circle. This is also 330 degrees. And you could just go look at it on your unit circle, and that's going to be a negative 1/2. And so we can just pop that in here and then actually go through and do the multiplication. This will cancel this. And if we multiply across, we get negative rad 2 over 2. And that is the answer to that problem. Oh, wait, I missed a sign. Holy moly. Negative times a negative is a positive. Okay, so there you go. That is the end of 7.4. And we are going to be following this up with a varsity. I decided with these guys to have you only do the expansion and evaluation of these. There are a bunch of problems where you can actually utilize these formulas to do identities, but I figured that you're identitied out by now, so you're welcome. Toodaloo. I will talk to you later.